Hi everyone, in this video we will see how to solve exact equation. Now an equation of the form m of x comma y dx plus n of x comma y dy equals to 0 is said to be exact if there exists a function f of x comma y such that partial derivative of f with respect to x is equals to m and partial derivative of f with respect to y equals to n. Now if you can find this function, if there exists this function such that this happens, then we say equation star is exact. Now the solution of star is given implicitly by f of x comma y equals c, where c is an arbitrary constant. Now to test for exactness, we simply check that partial m with respect to y equals to partial n with respect to x comma y, n of x comma y. Now this is known as a condition for exactness. If the partial derivative of m with respect to y coincide with the partial derivative of n with respect to x, then equation star is said to be exact. Now let's see how to solve exact equations. We'll look at some examples on how to solve exact equations. Now example 1. Determine if this equation is exact and hence solve. So to check for exactness, we see that m equals to 5x plus 4y and n equals to 4x minus 8y cubed. So we have partial m, partial y. So if we differentiate 5x with respect to y, this is a constant, so it becomes 0. Differentiate 4y with respect to y gives us 4. And then we differentiate n partially with respect to x. So differentiate 4x with respect to x gives 4. And then this is minus 8y cubed. We treat this as a constant. So differentiate this. A constant with respect to x gives 0. So partial m partial y equals to 4, which is the same thing as partial derivative of n with respect to x. So it implies that this equation is exact. Now since it is exact, it implies that there exists a function f of x comma y such that partial derivative of f of x comma y with respect to x is equals to m, which is equal to 5x plus 4y, and partial derivative of f of x comma y with respect to y equals to n, which is equal to 4x minus 8y cubed. Let's call this equation 1 and call this equation 2. So to solve this, we need to determine f of x comma y. And so to do this, we integrate equation 1 with respect to x and also integrate equation 2 with respect to y. So if we integrate equation 1 with respect to x, we will have f of x comma y equals, integrate this with respect to x, that is, we are treating y as a constant. So if we integrate this with respect to x, 5x with respect to x gives us 5x squared over 2 plus integrate 4y with respect to s gives us 4xy plus an arbitrary constant. But because we are integrating with respect to x, treating y as a constant, our constant will be a function of y. So we have g of y. Now we also integrate 2 with respect to y. If we integrate this with respect to y, we have f of x comma y equals integrate this with respect to y, we have 4xy. Integrate this with respect to y, we have minus, that is, we have 3 plus 1, that's 4 over 4, that's 2y raised to power 4, plus, since we are integrating with respect to y, we are treating x as a constant. So our constant of integration will be a function of x. So let's call that h of x. Now this is f of x comma y. This is also f of x comma y. So if you compare these two equations, we see that there is 4xy here, there's 4xy here. Now for this to be equal, it must be that g of y is minus 2y raised to power 4 and h of x is 5x squared over 2. So it implies that f of x comma y equals 5x squared over 2 plus 4xy minus g of y, which is 2y raised to power 4, or 4xy minus 2y raised to power 4 plus h of x, which is this. So this is our f of x comma y. And so the solution to our exact equation is fx squared over 2 plus 4xy minus 2y raised to power 4 equals to an arbitrary constant c. And let's see another example. Determine whether this equation is exact and hence solve it. So let's see, for this, our m is x plus sine y, and then n of x comma y is x cos y minus 2y. Now to check or to test for exactness, we have to show that partial m partial y equals to partial n partial x. So partial m partial y equals, so we differentiate this partially with respect to y, keeping x as a constant. So this gives us 0. Differentiate sine y with respect to y gives cos y. So partial n partial x equals, so if we differentiate this with respect to x, we can apply product rule here, keep this constant, differentiate this with respect to x gives us, if we keep this constant and differentiate it with respect to x, cos y with respect to x is 0. So we have 0 here. Also keep this constant, differentiate x with respect to x gives us 1. So 1 times cos x gives cos, 1 times cos y gives cos y, minus 2y, differentiate 2y with respect to x gives 0. So we see that partial m partial y equals partial n partial x. So it implies that this equation is exact, and hence there exists a function f of x comma y such that the partial derivative of f of x comma y with respect to x equals m, and that is equal to x plus sine y. Let's call that equation 1. And partial f of x comma y with respect to y equals n, and that is equal to x cos y minus 2y. Let's call that equation 2. So what do we do now? We now integrate equation 1 with respect to x and also integrate equation 2 with respect to y. So if I integrate equation 1 with respect to x, if we integrate this, we will have f of x comma y equals, integrate this with respect to x. If we integrate x with respect to x, it gives us x squared over 2 plus integrate sine y with respect to x gives us x sine y plus the constant of integration. And in this case, since we are treating y as constant, the constant of integration will be a function of y. So we call that g of y. Now, we also integrate equation 2 with respect to y. So if we integrate the left-hand side with respect to y, we have f of x comma y equals, integrate this with respect to y, we have, so this is a constant, we are treating x as a constant here. So if we integrate cos y with respect to y, we have x sine y. This x here is this, so cos y with respect to y gives us sine y, minus integrate 2y with respect to y gives us y squared, that is y squared over 2. So we have y squared here, plus the constant of integration is going to be a function of x. So we have h of x. Now this is f of x comma y, and this is also f of x comma y. So if you compare these two, we see that we have s sine y here, there's x sine y here. So for these two equations to be the same, for them to be equal, it must be that g of y equals to minus y squared, and h of x is equal to x squared over 2. So it implies that f of x comma y equals x squared over 2 plus x sine y plus g of y, which is or minus y squared. So this is our function. So the solution, hence the solution to the original differential equation is x squared over 2 plus s sine y minus y squared equals. I hope you enjoyed this video. If you have any question or comments, drop them in the comment section. Thank you.